Hello, and welcome to the Light, Technical, and Colorimetric Measuring Laboratory of Regiolux. My name is Alexander Ross, and I am a developer for optics and lighting systems. We perform photometric measurements and evaluate them in accordance with the DIN EN 12464 standard. In addition, we perform colorimetric measurements in accordance with the international standard IES LM79. Today we measure flicker. The Standardization Committee, IES, defines flicker as the temporal change of luminance, and the luminance itself is a human's perception of the impression of brightness. Flicker is important for several areas: humans and technology itself.
Der Mensch selbst nimmt das bewusste Flimmern oder Flackern.
Humans can perceive flicker up to a frequency of 80 Hz. The evaluation method is the PSTLM. This information can be taken from the datasheet of the driver. The second method, the so-called SVM method, evaluates the stroboscope effect. For example, a worker working on a turning lathe with a rotating part, he shouldn't be able to perceive it as standing still. This is evaluated by the SVM method, which can rate up to 2000 Hz.
Jetzt kommen wir in den Bereich der reinen Technik. Das ist hier zum Beispiel.
Let's take a look at mere technology, in this case a digital camera.
Bis 5000 Hertz.
A digital camera works up to 5000 Hz. The method of evaluation here is the modulation depth. As for barcode scanners, the modulation depth is also used for assessment. However, they work with a frequency of up to 100,000 Hz. The bottom line is that it's not only the evaluation method, but also the frequency.
Nun zeige ich Ihnen die Flickerbewertung anhand.
Now, I'll show you the flicker evaluation using our test setup. On the one hand, there is driver A, and on the other hand, driver B, which we are evaluating today. We do this by means of a flicker meter. These drivers are connected to the luminaire Lovea for our system ceilings. First measurement with driver A.
Jetzt haben wir
Luminaire is in operation.
das Messgerät ist bereits in Betrieb.
We are getting very close to the luminaire and record the data.
Und zeichnen die Werte auf.
For driver A flicker of 2.6%, SVM of 0.019, frequency at 100 Hz. The PSTLM information was already taken from the driver's datasheet.
Den PSTLM-Wert habe ich bereits aus dem Datenblatt des Treibers entnommen.
Measurements have now been taken, and we have also just learned that cameras are flicker sensitive. When I point my phone camera towards the light, I can see if something negative shows up.
Zu schauen, ob sich da etwas Negatives abbildet.
To me, it looks quite normal.
Für mich sieht das ganz normal aus.
Installation of the second driver. Second measurement, driver B. Now, we'll perform another flicker measurement.
Und jetzt können wir auch hier eine Flickermessung durchführen. Und die Werte übertragen. Das ist jetzt schon auffällig.
Immediately, you can see that the flicker percentage is 50%. The SVM value is 1.9.
VM-Wert bei 1,9. Auch bei diesem Treiber.
Now let's also check the driver with a cell phone camera. Driver B is clearly different from driver A. Taking a good picture would be impossible. What does all this mean for us humans, or for the technology? How can we further determine and apply it? For this, we need the international standard, IEEE 1789-2015. This standard includes the following graph. As you can see, the x-axis represents the modulation frequency, and the y-axis the modulation depth. The chart is divided into three sections. 1. Safe. 2. Moderate risk. 3. High risk. So how does this affect humans? Could it be harmful to our health?
Jetzt schauen wir uns noch
Now let's take a look at the camera application. This graph is published by the ZVI, and again, you can see the modulation frequency on the x-axis and the modulation depth on the y-axis. This chart is also divided into 3 segments: green, orange, and red. Let's take a look at driver A. At 100 Hz, there is about 3% flicker. This is represented by the green area. At 100 Hz, driver B had 50% flicker, which is in the red area. As you can see from this chart, the ZVI also defines sections for the barcode scanner. Again, the modulation frequency is represented on the x-axis and the modulation depth on the y-axis.
aufgetragen und auf der Y-Achse die Modulationstiefe.
At 100 Hz, driver A shows a modulation depth of approximately 3%, meaning we are completely in the green area. Also, driver B at 100 Hz with 50% modulation depth is completely in the green area. That means both applications would work in the barcode scanner area. When using a barcode scanner or having an illumination task using a barcode scanner, it is important to further investigate the higher frequencies.
In Bezug auf den höheren Frequenzbereich.
In most cases, not all information is included in the driver's datasheet. That's why we need to go deeper, perform analysis, and even contact the manufacturer of the driver in order to obtain the information needed. We have learned where flicker evaluation is necessary. On the one hand, it is human beings itself. On the other hand, it is the combination of humans and technology, and eventually technology alone. We have also understood that it is important to carefully choose the correct driver. That is why we at Regiolux are making sure that the drivers meet the minimum normative requirements. If you are looking for a solution, please feel free to contact the Regiolux team.